Hello everyone, I'm Chelsea Partridge, Supervisor for Brevard Soil and Water Conservation District, and welcome to Conservation Conversations with Chelsea. This video series interviews people that are involved with conservation, learn about what they do, and we learn about how we can get involved. This is our first in-person, non-Zoom recording of this video series, and we're here at Merritt Ridge in Merritt Island. Today we're talking with Steve Beeman, founder and president of Bmats LLC, and he has created an incredible floating wetland system that we're going to hear about today, as well as his 43 years of experience in conservation. Thank you for joining us today, Steve. So Steve, tell us about yourself and how you came up with the idea for Bmats.
Well, I grew up in Texas. I lived on the Gulf Coast in the marshes there, and then I went to college in Hawaii, where I studied hammerhead sharks. And I moved to Florida in search of a job working on sharks, but there was nothing available then, so I went to work for the precursor to the Florida DEP, and learned about native biology and botany in Florida. And after 4 years there, I started a company growing and planting native plants on shorelines for erosion control. And that evolved into needing something to withstand the water fluctuations in Florida, because the water goes up and down, and a littoral zone that's dry is not contributing anything to cleaning up the water. So we designed the platform. My son came on board. We started a new company in 2001, and we designed a platform for floating wetlands, and finally got that done in 2009. We started Bmats, and it was initially just to keep littoral plants in the water. We didn't have any idea what a good job they would do for cleaning up nutrients and taking nutrients out of the water. One of my mentors in this process is Jim Swan, who lives on Merritt Island, blocks from here. And he told me early on that a floating wetland system will not work unless it's harvested, unless you can let the plants take up the nutrients and then remove the plants every once in a while to take those stored nutrients out of the water, compost them, take them out of the system. And that's what we based our entire model. That's how we got here.
So these floating wetlands are called Bmats, correct?
Yes.
So can you tell us exactly what these Bmats do and how they help the water?
Well, the problem with a lot of our lagoons and receiving waters, lakes, rivers, streams, is that we fertilize a lot. We have a big agricultural component in Florida and all over the country, but fertilizers don't always go to the target plant, whether it's sugarcane or vegetables or corn. You lose some fertilizer to the groundwater and to the surface water, which ends up in the streams and the estuaries and the bays and the ocean. So our idea was to capture some of that nutrient load prior to it going out of the stormwater ponds. Stormwater ponds are a good feature. They trap a lot of nutrients, but you have to have something there to remove the nutrients from the water. Stormwater ponds in and of themselves are considered to be stormwater treatment areas, but they really don't treat the water for nutrients. The only way to get dissolved nutrients out of water is with some kind of plant. So you can either put something out there along the shoreline or floating that will take up nutrients and then you remove it, or those nutrients are going to grow something you don't want, like algae or hydrilla or duckweed or something like that.
I want to follow up a little bit on what you were just saying about fertilizer. I know fertilizer is a big issue here in Brevard County. We have fertilizer bans during the rainy months to keep fertilizer from essentially just washing straight into the lagoon. So do you think fertilizer is the biggest problem, or what do you see as the biggest nutrient introduction to these water systems, specifically here in Brevard County and the Indian River Lagoon?
Well, it's interesting. It's really not exactly what you'd expect. Harvey Harper did a study in 2014 where he categorized all land uses as to their loading of nutrients into receiving water. And he compared all existing land uses to state parks, which have almost, that's the baseline. The worst culprits for loading nutrients into receiving water are actually pastures. Second to that is row crops and nursery operations. Row crops can be sugarcane, can be vegetables. It's commercial farming where you're actually growing plants in the ground. Nursery operations also come in like close third, and then you follow that by high density residential, and next is light industrial, and then just moderate residential, and then parks, including golf courses, baseball diamonds, passive parks, where they have a lot of grass. Those are pretty far down there, and so it's amazing that everybody thinks, well, golf courses are going to pollute the water more than anything else. It's actually pasture.
Interesting. So where was that study area done? Because was that done where there's a higher agricultural density than Brevard County, or is this what you see pretty much across the board?
It's actually he studied sites all over Florida, and it's interesting because the highest nitrogen and phosphorus uptake rates we have at the ponds that we monitor for Brevard County. The highest one is in Scottsmore, and it's a pond surrounded by pasture. And so then you go to different places. A lot of the runoff directed to some of these ponds comes from agricultural area. Some of it is purely residential, and so it's a matter of how big the pond is, how much storage there is in it, and how long it's been going like that before we started treating.
So let's get into the science of this a little bit. So we talk about nutrients and runoff being bad for waterways, but what is it about nutrients that is bad, and why the Bmats help so much with that? Can you explain a little bit about what that is? Because most people, they think of nutrients, they think that's a good thing, but we know too much of nutrients can be bad. So can you talk a little bit about that?
You hit the nail on the head. Everything and everybody and every plant and every animal on the planet needs nitrogen and phosphorus. We all need it to grow. We need it to produce food. We need it to grow grass. We need everything. The problem is, like you say, too much. And so when the loads exceed the capacity of a water body to grow healthy plants, then they start growing plants that don't help the waterway. For example, you could get a hydrilla infestation, which in small quantities is actually good. It cleans up the water, but once it reaches a proportion where it's topped out at the surface, it actually shades the entire lake and kills fish because of the cover, robs the oxygen. Duckweed's the same way. Algae is the same way. And so now you get to a point where you have such a high nutrient load that algae is now not the problem, but cyanobacteria, which is blue-green algae. Blue-green algae is actually toxic to plants and animals and people. There is some discussion as to whether the brown tides we had in Brevard County were a direct result of too much nutrient runoff from the canals going into Indian River. A guy named Gary Payne, working for the Department of Environmental Protection, did a study for, I think, 4 years on South Florida canals. And his goal was to determine what the difference was between all of our canals that are all over South Florida and a typical natural stream. His idea was to look at the trophic index to see which plants and animals grew in natural streams and did they occur in canals. But part of his study, which is the part that I keyed on, was he did nitrogen and phosphorus sampling in all these canals. A lot of them have high nitrogen and phosphorus loads that end up going unchecked, untreated into the estuary. We have 2,300 miles of canals, I believe is the number. and almost all of them go unchecked into the estuaries or the bay. Some down in the Homestead area go right into Biscayne Bay. On the west coast, they go into Caloosahatchee or out. But that's why we have such huge blue-green algae blooms in Lake Okeechobee, and then they release that water. It goes down to the two estuaries, north or east and west, and so we have toxic algae blooms coming to the coast from Lake Okeechobee, and that's released as a result of their desire not to have a flood.
Right. So the Bmats in the plants, they actually absorb some of that nutrients in the root systems that kind of go underneath your mats. And I'm pointing out this way. You can kind of see behind us too some of these floating wetlands here, these Bmats. So the roots take up those nutrients and help keep it balanced. Correct?
Right.
So what do you do with the Bmats? So these are pretty full ones here that we see. They've got a lot of vegetation on them. So what happens next? Because you mentioned you have to remove things to actually get the nutrients out of the water. So do you harvest the plants from these? And what does that look like? What's the process there?
Yes, we do. That was our founding principle. Thanks to Jim Swan. We started out with the idea that we would put these islands out, let them grow for a year, come back, and they grow in a pot which has holes in it. So the roots spread out from the pot out into the water below the mats, and then the tops grow for it. So our original thought was we would take these out and pull the whole pot, plant everything out, and replace it once a year with a new pot with a new plant. And we did that for several years. But we realized after a few years that we weren't keeping up with it. As you can see, these mats were harvested five weeks ago.
Oh, wow.
And they're
This
already
is all
grown
5
up to the point.
weeks.
Yes.
Wow.
And so what we do now, we've started this in the last year or so as a pilot program where we take the mats out of the water, we cut the tops, called the shoots, down to the mat, we roll them over, we take the roots off the bottom using a rake and cut all the roots off the bottom and then put them back out. And we leave the part of the plant in the pot. It's called the meristem, the meristematic region. We leave that and let it grow out again. So you get almost instant growth. Within a week, you have an actively growing plant again. And it's better for the mats. Changes their life cycle from maybe 3 to 5 years to maybe 8 or 10 years.
Oh, wow.
So now we can keep using them. The difference is we now do this every 4 months.
Wow.
We come in here every 4 months, take everything out, and the total biomass may or may not be more, but the nutrient harvest is considerably more. And we're documenting that now at a study in Tampa with Dr. Sarah White from Clemson, where we have 10,000 square feet of Beemats. Five, and each one, there are 10 1,000 square foot islands. These are 575 square feet. So
wow.
You can see quite a bit
smaller.
Yeah. They're twice as big. And we harvest 5 of them by trimming, with the process I described. We harvest 5 of them every 4 months. The other 5 we leave, and we'll harvest them. The first time will be next March. We'll harvest them the old way. We'll take out all the plants and then replant them with new plants. And then we're doing a 3-year study to determine which technique actually gives us the most nitrogen and phosphorus removed from the plant. We suspect it'll be the trimming method because getting nitrogen and phosphorus out of the water depends on an actively growing plant.
Right.
And so if you leave these for too long, say a year, those plants slow down after 4 or 5 months, and then they come to a point where they're actually stalled and not taking up any new nutrients. And if you leave them too long, they actually start dying back and releasing those nutrients back into the water. So that's the key, is not to let them get to the senescent stage where they're dying and releasing nutrients back into the water, which again is the same problem with planted shorelines. Unless they're harvested in the fall, they die and put everything back in the water. So it's a constantly going program. We've developed some new tools. We've developed some new floating island material where we can actually pull these things out, cut them, cut the roots, put them back in. And we're doing that now every 4 months for most of our projects. Now there are some that we're doing the old way, but we're doing it twice a year with a regular harvest. And so we're trying to get a comparison of all of these techniques to see which ones work the best. The idea is to maximize our efforts, try to keep our costs the lowest we can keep them, and because most of our clients are cities or counties, and most of we have some private accounts now because we're an official BMP by the state of Florida. So when someone is building a new subdivision, they have to meet their runoff requirements. They can't discharge more nutrients off site than the raw land. So they have to build ponds and they have to do different things. And they can use baffle boxes, street sweeping, different things. And Bmats is one of those. We're one of 3 of the major floating wetland companies in the country, and we're the only one that is truly harvestable at a regular rate, and by far the least expensive of the floating wetlands. And that's by design. We don't want to, of course we want to make money, but we don't want to become filthy rich. We want to help keep nutrients out of the Indian River.
That's awesome. So tell us a little more about what you do once you harvest these plants. When you pull them out of the pot or when you just do the trimming, what do you do afterwards with those plants?
Okay.
Do they become compost? Do they just get thrown in the trash? I mean, what happens then?
Okay, well the original way we harvested, we took everything out. So we would basically take them back to our nursery in New Smyrna Beach, cut the tops, cut the roots, take the meristem out and divide it up and make new plants. And take the pot and reuse it. That is labor intensive. The cost of doing that is more than just starting new plants and starting over. But we do it. That's the way we do that. But fortunately for us, that's a small percentage of what we're doing. With the harvesting techniques, basically we're harvesting tops and roots, and it's all biomass. We take a sample, a representative sample of every harvest. We put it on ice. We take it to Inco Labs in Orlando, and they analyze the nutrient composition in the sample, and then we extrapolate that. They give it to us in percent or milligrams per kilogram, and we extrapolate that to the gross weight of the biomass that we weigh, and we take it to the scale and weigh it. Now typically, if it's just biomass, we take it to one of the biomass landfill sections at whatever county we're working in, and they take it and compost it and use it as landfill cover, because it works out good for them to have an organic source. When they cover these cells that they've been dumping garbage in, they cover them with soil and with this material and grow grass to stabilize the slopes. So it's used as a countywide usually compost.
Interesting. So what sort of plants do you grow on these systems? And I love to see this one's actually moving. I don't know if that's picked up on the camera or not, but you can actually see this. We'll talk a little bit more about how these are anchored in a minute. But what kind of plants do you grow on these? Can you grow fruits, vegetables safely on something like this? Do you focus on natives? Is it based on the water? So tell us a little more about what you actually grow and how you pick what you grow on these systems.
Good question. We grow plants that are native to each region. We just did a project on Long Island, and they use local plants for Long Island. We did plant projects in Virginia. We used local plants. We actually imported seeds from Virginia area, grew the plants, and took them back up there. Here, when we're in freshwater, we use native Florida aquatic plants. It could be, it's usually got a grass. That one's better represented. It's usually got a low-growing grass around the edge, and then a taller group in the middle. This pond is salt. This gets straight, during king tide, we get a straight inflush of salt water into this pond. pond from the estuary. So everything here is called a halophyte, saltwater tolerant plant. And so we use a lot of halophytes in some of the coastal plants, coastal ponds around Brevard County. So this is basically two different grasses. And then that grows some volunteer species. You see a lot of these plants in here have come in that we didn't. That's fine. They're still taking up nutrients. The key is to make sure we get them out before they steam. We're doing that every fall. Now, as far as vegetables, we've done some samples, and Sarah White at Clemson has actually done studies growing Swiss chard and basil in Bmats. And we grew butterhead lettuce and romaine lettuce at our pond in New Smyrna Beach. They grow very well. In fact, the basil uptake rate is better than a lot of the native plants. The drawback is that in a stormwater pond, it's hard to use a vegetable that is meant for human consumption if there's any coliform bacteria in it. You can't do that. You can use it for cattle feed, but still, it's just not something that's actively done. Now, there are some really big possibilities for growing vegetables in the Mississippi River Basin because there they've drained all the fields, or a lot of the fields, with tile drainage. They grow corn, and they grow corn for ethanol. So the water goes down and comes out into these ditches, these tile ditches that drain into, eventually streams in the Mississippi and the Gulf. You could fill those ditches up with Bmats, with basil or lettuce or whatever, and capture all the nutrients that just came off the field. There's no coliform bacteria there because there's no cattle. There's cornfields, no septic. So everything coming in there should be pretty clean. All it's got is a bunch of nitrogen and phosphorus, mostly nitrogen because they're using nitrate fertilizer. So if you capture that in this, now you have a crop you can sell, and at the same time clean up the water before it goes off of your farm. We've pushed that idea for a few years now. We haven't gotten anywhere.
I love the idea, though. I think that's awesome, especially if you can. You're doing 2 for 1, more or less, by being able to clean up the water and actually produce something that provides further benefits than just the water cleanup. So exactly. I hope that does pick up. I think that's really cool.
Yeah, there's a dead zone in the Gulf of Mexico every year, and it's because of nutrient runoff from the Gulf, or from the Mississippi Basin and the Atchafalaya Basin, mainly Mississippi. And the nutrients cause algae blooms, which then when they hit the water, the salt water, they die, and that causes a huge biological oxygen demand, and fish kills, and basically it sterilizes acres and acres of the Gulf. So it's an ongoing problem. Everybody knows it's there, and nobody really has the desire to go upstream and fix it as a problem.
Let's talk more a little bit about the BMAX Structure, because I saw this one. We've got some bird activity over here too, so hopefully that's not too noisy. But I want to talk about the structures of these, because we just saw this pond rotating around. So these are anchored somehow so that they stay in place. Is that correct?
That's correct. We use concrete anchors with the eye bolt. We use 100 pounds per 350 square feet. So these are all 512 square foot islands. So we have 2 of them. We have 200-pound anchors. There's usually a float. That means there are missing islands that are floating around here loose somewhere.
Okay.
But that float goes to the anchor. The island is attached to that, and then they just basically spin like a sailboat at anchor in response to the wind direction. So they cover a big area. This one will cover all the way back out to that other island, depending on which way the wind's blowing. Obviously, it's blowing this way because our hair's all going clean. So it's blowing this way, so that you won't see many of the anchor floats because they're on the other side of the island.
So how do you actually, when you go and do the harvesting, do you go out there on boats? Do you pull them onto the land?
Right.
So what do you actually do there?
We do. We have a rack on wheels that we lower into the water. We go out with a boat and put these things are a series of strips that are connected together. So we take a strip at a time, 8 feet wide, and we bring it up onto this rack, and we pull it up with a winch onto the land. And we cut the roots, put it back in. So it's a fairly simple but time sensitive project because we don't want to keep them out. Get them out, and then
So,
hook them back in.
so I know you have these here in Merritt Ridge, and you've got more in Brevard County that you've, I guess, contracted with the county itself and some of the municipalities. So can you tell us more about other locations in Brevard? Do you know how many of these you have deployed? What the approximate nutrient load that you're pulling out of the waters here in Brevard?
We do. We have, I think, now 8 different systems that we do for Brevard County. We have 5 or 6 that we do for the city of Titusville, and we have 4 that we do for the city of Cocoa. And for the county, we've been doing this the longest in Brevard County for the county itself. We work with Terry Williamson and Virginia Barker's the one who started all this and got it all started up. Said you need to get out here and clean up my water for me. So we've been trying. The nutrient, like I said, we do a report as we take a lab sample. Every time we do a harvest, we get the lab results and we do a report to the county. And so we know exactly what we've taken out each 4 months. It used to be annually, now it's every 4 months. And then we sum that up in the year, and that tells us how many we've taken out. We started most of these in 2014. We did one of them, no, I'm sorry. We started one of them in 2014, which is Florida Boulevard on Merritt Island. Most of the others we did in 2016, part of an initiative by Brevard County to help clean up the river. And so they've been in place for 5 years. Over that 5-year period, we've taken up about 10, almost 11,000 pounds of nitrogen and about 1950 or close to 2,000 pounds of phosphorus out of the water that would go normally to the lagoon.
That's amazing.
It's a lot of nutrients.
Yeah. So you have some Bmats here in Brevard County. You mentioned Titusville, Cocoa. Earlier you mentioned Long Island, was it? And some other places. So where all do you have these Bmats deployed to?
We have them all over the place. We have, most of them are in Florida. It's hard for us to do installations in places, but we have. We've done some. We did one this summer in Baltimore on the bank of the Chesapeake Bay. We have some in Virginia, also on the other side of the Chesapeake Bay. We did one coastal area in Delaware. We've done, most of them though, have been in Florida, all over the state of Florida. We just did one in Cape Coral where we did several ponds in Cape Coral. Big one in Tampa. Just everywhere.
So you might not have one, but if you do you have like a big dream for deploying these somewhere? Would that be the Mississippi River Basin that you mentioned earlier, or someplace you'd really like to work or get these deployed?
Yeah, my big dream is to, like I said, we have miles and miles of canals flowing unchecked into the estuaries. I would love to get Bmats in those canals and capture some of the dissolved nutrients before they get into the estuaries. I would also like to get into either the STAs or Lake Okeechobee itself and put these in. We have a legacy phosphorus load in Lake Okeechobee of just thousands of metric tons of phosphorus tied up in the sediments on the bottom. Every time there's a hurricane or a big wind that comes through, that gets churned, and that feeds the algae blooms that we have, the toxic algae blooms. when they started this program to try to clean up Lake Okeechobee and send the water south through the Everglades and out into Florida Bay, they kept saying they were going to try new and different things. But they're not open to doing something like floating wetlands, and I don't know why. It's the South Florida Water Management District that is a problem for us. But I think that some floating wetlands in Martin County. Martin County is trying to direct some of this to use floating wetlands in some of the STAs in their county. So we'll see. But my idea would be if we could put massive floating islands in Lake Okeechobee and service them with a boat, bring the biomass over. We could use, instead of just using all natives, we could use something like vetiver grass that would have a market after value, so we can keep harvesting it and taking that money and putting it back into more floating wetlands. It's a huge dream, but it's realistic. I mean, I won't say it's not that hard to do because it would be tough, but it would be very realistic to actually clean up Lake Okeechobee, take some of the legacy phosphorus and handle all the new phosphorus coming into the lake using floating wetlands. You can do it in the inflow canals, you can do it in the outfall canals, you can do it in the STAs, which are becoming just basically toxic phosphorus storage. So you can do it. That's my dream.
So how can people implement these wetlands? If there's anyone that's working for a city, municipality, a water management district that might be watching this video and they think this is awesome, how can they contact you and find out more about implementing these Bmats?
Just call us. We have. I'm pretty social media illiterate, but I've hired someone now, a consultant, to do my social media. So we actually have a presence out there on social media now. We have a website, Bmats.com. All of our information is there, and we try to update it. Do that again. It's there. We don't really advertise. That's not really hard. We get a lot of referrals from the state or from the water management district, and so and we get referrals, quite frankly, from Brevard County and other people that have our wetlands out. You know, the idea is you can't harvest nutrients using passive means. You can't just build a hole, fill it with water, it's full of nutrients, and expect it to go away. It's not going. It's going to stay there. It's going to ultimately get worse. It's going to be concentrated in that pond, and then when it does flow out of there through a hurricane or high water or king tides or whatever, it's more toxic than it would have been just running off. You have to have something that is active. You have to have actively growing plants to take those nutrients out of the water, and you have to be committed to doing that. It's not something you do once and walk away.
Right, and like you mentioned before, you have to actually remove those plants too, because when they die, they'll just release all those nutrients back into the water. So it's something that has to be regularly maintained.
Right.
So what about people? Is there ways that people can get involved and help with this, or help spread the word? How can just a normal person get involved?
Well, we've had groups of volunteers doing floating wetlands. The project we did in Delaware, South Bethany Beach, Delaware, was a 100% neighborhood project. The project in Montauk on Long Island was 100% volunteers. We provided the materials, they bought the plants for their area, and then we sent one of our scientists there to help them and supervise, and they did it. So yeah, it's easy. No problem at all.
So are there any downsides to the Bmats? Any negative impacts? Do they use plastics? Or are you concerned about microplastic breakdown or anything like that?
Not really. The mats are made out of foam. The original ones we started with were made of EVA foam, but we've changed from those to a high density polyethylene foam, which doesn't break down as easily. And they have a shelf life. The EVA foam would break down after 5-6 years. So that goes to the landfill. That's the only thing. The plastic pots are made of nylon, and we use them over and over again. Eventually they will go to the landfill. We tried getting, having the pots made of a biodegradable plastic called Murel. The plastic is made out of cornstarch rather than petroleum based. And that was great, except that the person who manufactured them told us they would be fine in the water, and then when we took them out, we could plant them in the soil with the plant. So we start with a small plant, grow a big plant, sell that or plant it on a shoreline somewhere, and that was great. Then the soil microbes would break down the plastic and it would go away. The problem is that the water also broke down the plastic. I mean, we didn't have them in for a couple of months, and there was no pot holding the plants. So we don't have that yet. We're working on it. Our pot manufacturer just sent us a sample of a new biodegradable plastic. We're still trying to get that worked out. But other than that, there are no downsides. The plants are plants. We take them out, we reuse the mats, we reuse the pots, and then we either compost or reuse the plants themselves. I mean, when we do have to dispose of the mats or the pots, it's like once every 5 to 10 years. It's very low impact on, and if you look at this island, the mat itself and the pots themselves are a very small component of this. It's 95% plants. It's almost all plants. The mats and the pots are just there to hold them up. That's the whole thing. We don't do anything here. All we do is put plants in the way of nutrients. They do what they do. They grow up. They take all the nutrients out of the water, take nutrients out of the water, and then we take them out.
So looking out, you have a lot of mats out here. So how many Bmats do you have out here, and what's the magic behind that number? Is there a science to how many that you put in the waterways that you do?
There actually is. There are 33 islands in this pond. Each one of them is 512 square feet, so it's about 16,500 square feet so each island has 1,280 plants. There are 2.5 plants per square foot on each island. So we've got 16,500 square feet, multiply that times 2.5, that's how many plants are out here on this pond. The magic number of 5%, that 16,500 is 5% of the surface area of this pond. That number was arrived at through study by University of Central Florida, Dr. Wanalista and Chang, at Clemson University by Dr. Sarah White. ERD did a study at Patrick Air Force Base. Dr. Dr. Harvey Harper, take out Wheeler. So Dr. Harvey Harper did a study at Patrick Air Force Base, and then there was another study at Virginia Polytechnic. But all these studies seem to come to the conclusion that we could remove enough nutrients to keep a pond in balance by using 5% coverage. Now there are some exceptions. The ones we planted in Virginia have 10% coverage, but the Chesapeake Advisory Board expert panel doesn't allow any harvest up there. So once they put them in, they have to leave them. We have 10% on 2 ponds in Titusville that experienced a wastewater leak. So the nutrient loads.
Sandpoint Park?
Sandpoint Park.
Okay.
We have Sandpoint Park there are 2 ponds there. We just harvested one. We're going to harvest the other next week. And that one, the plants grew really fast. And that was after months of remediation on the part of the city, where they actually took the water out after they fixed the leak. They took the water out and trucked it to their treatment plant and ran it through there. So they did as much as they could. Then we put the floating wetlands in there, and there's still a tremendous nutrient load in there. So rather than 5% there, we did 10.
All right, well, thank you for joining us today, Steve.
You're welcome.
It was a pleasure talking with you, and I'm so glad we finally got this opportunity. Steve and I have been talking about filming this video for a few months, but just had trouble getting our schedules to line up. So I'm so glad we were able to do this.
Thank you.
Thank you. And thanks everyone for joining us and for listening in. Again, this is Conservation's Conversations with Chelsea. I'm Chelsea Partridge, Supervisor for Brevard Soil and Water Conservation District. And if you like this video, please feel free to share. But if you have ideas on people you want me to talk to, topics that you're interested in, please let me know. I do these videos regularly and would love to make sure I do things that interest the people watching it. So thank you for joining us.